So we will start with problems. Let's go to exercise 5.2. Now in exercise 5.2, the first problem says find the coordinates of point P if P divides line segment joining the points this and this in the ratio 2:3. The problem says exercise 5.2 problem number 1, it says that you have a segment AB, the coordinates of A and B are given and the ratio is given as 2:3 and you have to find the point of coordinates of this point P which is going to divide AB in the ratio 2:3. That is the problem. Okay, let's come to the solution. Now, since you are given the coordinates of 2 points and you are asked the point which divides the segment in the ratio 2:3, it's an external division problem. So we know that there is going to be section formula being used here. How do you use section formula? So let's look at section formula. So by section formula, what is going to be H? H is going to be mx2 plus nx1 upon m plus n, while the y coordinate k is going to be my2 plus ny1 upon m plus n. Alright, now substitute. What is x1 y1? Minus 1 comma 7. What is x2 y2? 4 comma minus 3. Right? So let's substitute. So therefore H equals to, the value of m is going to be 2, but we will have to first mention that. Okay, let the ratio in which P divides segment AB be m:n. So you have assumed that the ratio in which P divides segment AB is m:n. Then by section formula you will have this formula, right? Now let's substitute. What is the value of m? M is equal to 2, n is equal to 3. So H is going to be 2 into x2. What is x2 now? 4. 2 into 4 plus n value, where is n? 3 into x1 minus 1 divided by 2 plus 3. And similarly, what is going to be the y coordinate? The y coordinate is going to be m into y2. So m is 2, y2 is going to be minus 3, plus n is going to be 3, and y1 is going to be 7, divided by m plus n, which is 2 plus 3. Alright, now therefore what is H? 8 minus 3 upon 5. What is K? Minus 6 plus 21 upon 5. So what is H? 5 upon 5, which is equal to 1. And what is K? Minus 6 plus 21, that gives you 15 upon 5. 15 upon 5, which gives you 3. So what is going to be the coordinate of point P? So you have your answer. PH comma K is going to be 1 comma 3. That finishes the problem. So exercise 5.2, now we go to the problem number 3. We are given P, we are given Q, we are also given the point T which divides PQ in a particular ratio. We have assumed that ratio is m is to n. Our duty is to find out the ratio m is to n. This is what we have to find out. Now, P we will assume as x1 comma y1, Q as x2 comma y2, T as h comma k, and we will say let the ratio in which T divides segment PQ be m is to n. Be m is to n. Okay, so we have to find out m is to n. Okay, we will here mention let P divide T divide segment PQ in the ratio m is to n. Okay, so T is dividing segment PQ in the ratio m is to n. P is given, Q is given, T is given. We have to find out m is to n. Right? By section formula we know h is this, k is this. Now one thing we need to remember here in this problem is that we have to find out the ratio m is to n, meaning we have to find out the value of m upon n. Do not think you have to find out m separately and n separately. You don't need m and n values separately. You need the ratio m upon n. So if you need the ratio m upon n, what do? We say we take any one of these two. Any one of these two are going to give you the answer, right? So either take this or take this, any one, not both, because anyways both are going to give you the same answer. It is a waste of time if you do both, right? So follow with one. Let us take h. So now, what is the value of h? For us, h is minus 1 equals to m we don't know. M into x2, the value of x2 is 6 plus n into x1, the value of x1 is minus 3 divided by m plus n. Alright, we will not write k again because as I said, any one will give you the answer. We have selected the x coordinate, we will use the h value and we will get the answer m is to n. Let's see how. So therefore, take the m plus n here, minus 1 into m plus n is equal to 6m minus 3m. Therefore, minus m minus n is equal to 6m minus 3m. Therefore, minus m minus 6m is equal to minus 3m plus n. M on one side, all m's on one side, n's on one side. This is what we did. So minus m minus 6m on one side, minus 3, and this minus n goes there, it becomes plus. So you have plus n that side. Therefore, now minus m minus 6m gives you minus 7m. This gives you minus 2m. Therefore, minus 7m. So what we will do is you will keep the 7 on one side. M upon n is equal to minus 2 upon minus 7. The minus and minus cancel each other, and then you have m is to n is equal to 2 is to 7, and that gives you your final answer. So what is the final answer? The point T divides, so point T divides segment PQ in the ratio 2 is to 7. Okay, so now we go to the problem number 4. The problem number 4 says that you have a circle having diameter AB and there is a point P which is the center. We all know from geometry from the previous years that we've studied that P is the center of the diameter AB, then AP will be congruent to PB. Why? Because AP and PB are going to be radii of that circle, right? So AP is going to be congruent to PB. This property we know, right? Keep that in mind. Now we are saying let A x1 y1 be 2 comma minus 3, B x2 y2 we don't know, that is what we have to find, P h comma k b minus 2 comma 0. We are given segment AB is the diameter and we are also given point P is the center, right? What do we have to find? We have to find B x comma x2 comma y2 is how much, right? Now let's go to the solution part. So what does the solution say? We'll start the solution here. So solution. Now the solution says that by midpoint formula, H is equal to x1 plus x2 upon 2. K is going to be y1 plus y2 upon 2. So therefore, the value of minus 2 is equal to 2 plus x2 upon 2, and here the value of 0 is equal to y1, that is minus 3, plus y2, we don't know that, divided by 2. Cross multiply. Minus 4 is equal to 2 plus x2, and here 0 is equal to minus 3 plus y2. Therefore, minus 4 minus 2 is equal to x2, and here 0 plus 3 is equal to y2. So therefore, you have x2 is equal to minus 6, and here you have y2 equals to 3. So your final answer is going to be B is equal to minus 6 comma 3. That finishes the problem. Okay? Copy down. Okay, students, so here now we are on exercise 5.2, problem number 5. What all things we are given? We are given that there is a segment AB, there's a segment AB in which point A is 8, 9, point B is 1, 2. There is a point K, 7 which divides this segment in the ratio m is to n. So what all things we have to find? The unknown is K, so we need to find the value of K, and the unknown is the ratio m is to n, so we need to find out the ratio m is to n. Alright? Now, how do we find out? So first, since there is a ratio, we will use section formula. So in solution, we begin with the section formula. Solution by section formula. By section formula, you will have the value of A here. We have assumed here A, not H comma K. We have assumed A. Why did we assume A comma B? Because already K was there here, right? So we wanted something different here, and therefore A comma B. So A is equal to mx2 plus nx1 upon m plus n, and B equals to my2 plus ny1 upon m plus n. Okay, clear? Now let's substitute. So, do we know the value of a? No, we have to find out, but it's given as k. Let's substitute k. M we don't know. What is x2? The value of x2 is 1. What is the value of x1? 8 divided by m plus n. Similarly, here the value of b is 7. What is the value of m? We don't know. What is y2? 2. N into y1. What is y1? 9 upon m plus n. Alright, next. Therefore, k is equal to, now you have m plus 8n upon m plus n. Here you have 7 is equal to 2m plus 9n upon m plus n. Now, we did an earlier problem in this exercise. We did one problem which was problem number 3. The problem number 3 in the same exercise, where you found out the ratio m is to n, in which I told you that you need any one of these to find out the ratio, right? So here also we will use this and find out the ratio m is to n, and then once we get m is to n, we will substitute here and get the value of k. So that is the way we are going to approach this problem. Okay. Now we have, therefore, let's first quickly use this and get the value of m is to n. So we will say, now 7 into m plus n is equal to 2m plus 9n. So 7m plus 7n is equal to 2m plus 9n. So 7m minus 2m is equal to 9n minus 7n. So 5m is equal to 2n. So m upon n equals to 2 upon 5. So you got the ratio m is to n. M upon n is 2 upon 5, means you got the ratio m is to n. Right? Now this value we will substitute here and we will get the value of k. So we will say, therefore k equals to, so this is your Roman number 1, this is your Roman number 2, this you got from 2, and now you will say, therefore k is equal to 2 plus 8n. Wait, we will solve k further. So we will say k into m plus n. So k is equal to, now 2 plus 8 into 5 upon 2 plus 5. M plus n gives me 2 plus 5. So you have k equals to 2 plus 40 upon 7, which is 42 upon 7, and therefore k equals to 6. So you got the value of k. Alright, so this is from Roman number 1. From 1. And this you have got from 2. Okay, clear? Okay, now we are on exercise 5.2, problem number 7. What all things are given to us? I would suggest first read the problem in the textbook, the problem number 7. Just have a look, all of you. What all things are given to us? So we are given that there are 3 points, x1, y1, x2, y2, x3, y3 as minus 7, 2, minus 2, 8, 3. Now before that, let us understand what a centroid is. Assume there is a triangle, and then in that triangle you have got 3 medians, What do you mean by medians? Medians are those segments which join the opposite vertex with the midpoint of the opposite side. Joining a vertex with the midpoint of the opposite side. That is called median. So this is one median, this is another median, this is the third median, and all of these medians have a common point of concurrence. So this point of concurrence where the three medians meet each other, that point of concurrence is called as the centroid. So that's basically the centroid. You want to find the coordinates of this centroid. So you want to find the coordinates of this point here. Okay? Now, let us assume x1, y1 is this, x2, y2 is this, x3, y3 is this x1, y1, x2, y2, x3, y3 are the vertices of the triangle. So these three are the vertices. Okay? They are the vertices of the triangle. So the vertices are assumed as x1, y1, x2, y2, x3, y3. The centroid is assumed as a, b. And you have to find out what is a, b. You have to find out the centroid, value of the centroid. So how do we begin? Solution. We have a centroid formula. So by centroid formula, you have got A is equal to x1 plus x2 plus x3 whole divided by 3. Similarly, B will be y1 plus y2 plus y3 the whole divided by 3. Alright? Clear? So this is the formula. Now let us substitute. So substituting, you have A equals to, so when you substitute, you have A equals to x1. What is my x1 value? Minus 7. x2 is 2. x3 is 8 divided by 3. Similarly, B is going to be y1 6, y2 minus 2, and y3 is 5, the whole divided by 3. Therefore, 3a is equal to minus 7 plus 2 gives you minus 5 plus 8 gives you 3. So you have 3a equals to 3. Here you have 3b equals to 6 minus 2 gives you 4, 4 plus 5 gives you 9, so you've got 9 this side. So 3a is equal to 3, 3b is equal to 9. Therefore, a equals to 3 upon 3, b equals to 9 upon 3. So a is going to be 1, b is going to be 3. So my final answer, the centroid is 1, 3. Okay, you can say the centroid is 1, 3, or you can say the coordinates of the centroid is 1, 3. Both ways. Okay, that finishes the problem. Copy down.